Now you gotta ask yourself, is my response gonna be nonsense? Or the theory of relativity that they're thinking is real? Oh, fuck off. You know
The
where this is
cause.
going.
Causality. Thank you, Brilliant, for...
Go the fuck away from me, advertisement. Alright, so here we are, fast and light travel rocket idea, and they're gonna say causality nonsense because they don't know how even the speed of light works. Let's watch this stupidity. I am indignant at this point of anyone who gets physics wrong. But this is especially wrong.
For sponsoring this video. If a missile can travel faster than light, then it can blow up a target even before being launched. I'm not joking. Here's what I mean. Say we want to
I don't think he's joking. He's just wrong.
blow up an alien base on an alien moon very, very far away. Why? Because
Light years away.
we're going to discover something fascinating. So we use a very advanced hypersonic missile, but for now this missile is traveling slower than the speed of light, normal stuff. So it's going to take a few years to go and blow up its target, right? But if there are some observers nearby witnessing this event and they're moving very close to the speed of light, they would disagree on how long it took for the missile to go and blow up the target.
Because they clearly wouldn't be compensating for their speed.
Some would say that no, it only took a few days, versus others would say that it took a few decades for it to happen, and that is fine because this is relativity. The time
We're allowed to be stupid.
between events is relative. It depends on reference frames.
No, it really doesn't. I've gone through this before. The train experiment. Events that... Well, let's just keep watching. I'll make my notes later.
But you know what's not relative? The order of events over here. Everyone would agree that the missile was launched first and then the target was blown up, because the cause
Obviously.
comes before the effect.
Okay, so you don't get a complete F on everything, you got one thing right. Yeah, you shoot the missile, it goes through space, it heads there. But what you're also forgetting is that light from billions of years ago still took billions of years to get there, and no one's confused about that. But you're saying moving faster than the speed of light is gonna make it so that somehow cause and effect is gonna be different. No, it just takes less time to get here. Trust me on this one. If you don't, stay tuned. You might still learn something anyway.
Kind of makes sense, right? Unless the missile is traveling faster than light. If this missile is traveling faster than light,
Look, I'll applaud you for your enthusiasm. I like the whole idea and everything else, but the problem is you're working off of old, outdated information that really was just a hypothesis. And it was not, it was taken as dogma, and then you're just running with it. So, I'm sorry that you believe this. He genuinely believes this. He's not, like, imagining... He's not thinking that it is... Like, he's not trying to deceive, he's literally thinking this is reality. Because all other scientists believe this as well. It's sad.
right, then there will be some observers who will find that the target got blown up even before the missile.
Let me tell you something. Even if you're moving faster than the speed of light, you moved at a certain rate. Let's say that you moved exactly... Even if you moved 1 light second in order to get to your target, let's say you did something like that. So you're moving so fast that wherever you went, it took a second for you to get there. Light is still going to take its merry time to get all the way to wherever is observing it. So you would notice it exploding later, depending how far you are from the explosion. Obviously, if you are 10 light years away or whatever, you would notice, hey, it got sent, and then it would still take 10 years before you knew it exploded. It exploded way earlier, actually. It exploded instantaneously. And what you would get is the math is it didn't take nearly as long as it could have in order for it to explode. But you'd still find out that it happened way later after it exploded.
Missile was launched. And this is not just an illusion that is caused because light takes time to reach people's eyes. No.
Let's listen to
because
that.
The cause comes before the effect.
Very
That makes
clearly.
sense, right? Unless the missile is traveling faster than light. If this missile is traveling faster than light, then there will be some observers who find that the target got blown up even before the missile was launched. And this is not just an illusion that is caused because light takes time to reach people's eyes. No. As we will see in this video, it will be their reality. When things are traveling faster than light, some observers will find that the effect happens before the cause. Causality gets broken. But
again, for everyone trying to understand this at home or whatever else, one, different observers don't change the events. So the fact that they have different observations is irrelevant. If they're not compensating for distance, whatever, everything else, then okay. But here's the thing. How could something moving faster than the speed of light ever end up being seen as happening before the rocket? We haven't gotten to that point, so let's let him get to that point.
wait a second. Why does it happen? Why faster than light signals break causality? And even if they did, what's the big deal? Well, we can try to understand these things using space-time diagrams or Lorentz equations, but our goal over here is not just to understand. No. The hope of this...
If you don't say that it doesn't go into the past somehow as some reason it ends up exploding... Listen, in order for this to be any relevance, the signal of the light happens, and then you shoot the rocket. Thus, later on in the future for the rocket, but in the past, reality, stuff happens. I mean, I'm just wondering, what is your idea here?
Video is to try and rediscover these ideas step by step using intuition. So, if you're ready...
Don't say you're using intuition. Don't say that. Because you are not using intuition, sir. I'm gonna hear you out, but I'm just saying that is not what you're doing.
For this, let's begin.
Get ready with me at Source for Sports. They're experts at...
I need to press this button right.
For this, let's begin. The biggest challenge to doing relativity intuitively that I have found is that what you see is not what really happens. Here's what I mean. In our everyday life, the distances we're dealing with are so small, the speeds are so small compared to the speed of light, that we can pretty much ignore the time it takes for light to reach our eyes. We can say that light travels almost instantly, and therefore what we see is what's really happening. But that's not the case when things are very far away or when things are traveling very close to the speed of light. What you see can be very different from what really happened. Say the distance between the destroyer and this moon is about 1 light year, meaning light takes about 1 year to go from here to here. We've also placed a curious
Okay, so you're gonna find out that it exploded a year later.
astronaut very
Unless you're looking at gravity waves, which travel faster than light, question mark, maybe. That's an interesting thing.
close to moon because we want to understand what she sees. And don't worry about her. She has high-tech spacesuit, so she will be protected from the explosions. Don't worry. And also to keep things simple, let's fire a missile that's pretty much traveling at the speed of light. Our calculations will be very easy. We can do it in our head. So if you fire a missile that's traveling at the speed of light, it's going to take 1 year to go from here to here.
Yeah.
So it'll take 1 year to hit the target and cause an explosion. So one.
You know, if it goes half the speed of light, or I mean double the speed of light, it'll get there in half a year, meaning the total time between sending it and getting the signal is 18 months. You're still not finding out about it before the explosion. Unless something weird happens, which is what I'm waiting for him to say.
A year later, it'll cause a boom. That means the time difference between the cause and the effect is 1 year. But the big question is, what would she see? Will she see the same thing what we saw in our animation? No. Because when we launched the missile at this point, she's not going to see it because the light from here hasn't reached her eyes. In fact, if we keep track of a light signal, we'll realize this light signal and this missile will travel together because the missile is also traveling at the speed of light. So what will she see? Well, let's find out. So since the whole thing travels together, when this light reaches her eyes, the explosion happens. That means she will see the explosion and this missile being launched.
Yeah, but that just means that the signal reached her at the same time as the explosion. And that doesn't change causality, because, duh. Things still happen in order.
At the same time. Now, of course, you could ask that, hey, shouldn't light from the explosion also reach her eye? Yeah, but because we have placed her very close to the moon, we can ignore that. And that's the reason why we placed her very close to the moon, okay? So anyways, she will see both the missile being launched and the explosion at exactly the same time. But
yeah, she'll see it at the same time. The fact that it happened a year ago. So, at some point, a year from the thing being sent, the thing will explode, and the light from a year ago will finally reach her that it was sent. So the signal of flash, bang here is nearly simultaneous, and there's nothing wrong with this.
notice they didn't really happen at the same time. Right in front of your eyes, Einstein says, an example where you see something is not the same. What you see is not the same as what really happened.
I wish you understood that.
But now Einstein asks, can she figure out, based on what she saw, can she figure out what really happened? And I'm like, yeah, she can, because she understands basic physics. You see, you can say that, hey, the explosion, the boom happened right now. And although she received this image also right now, this image has been traveling, this light has been traveling for a year because it came from 1 light year away. Therefore, this light was created 1 year ago, and therefore the missile was launched 1 year ago, and therefore...
You're not wrong. That's what they would figure out. That's what... Where are you going to go off the rails?
She can perfectly understand that the missile was launched 1 year, after which the boom happened. Everything makes sense. Also notice, which is going to be super important for us later on, because this light has been traveling for 1 year, the radius of this is also going to be 1 light year. So just by knowing the radius of the light signal, we can figure out how long that light signal has been traveling. And lastly, let's imagine if we didn't know this number, we didn't know how far this was. Then to figure out how long it has been, what we can do is we can imagine running the whole animation backwards and then figure out how long it takes to collapse, how long this takes for the signal to collapse. That will tell how long ago this light signal was created, and that's another way in which we can figure out how long ago the missile was launched.
In reality, what we do is we say there's a standard candle or something else. we figure out some distances by using some mathematical stuff that has nothing to do with any of this light cone nonsense. Although I haven't seen your flaw yet. We'll get to that.
We're all prepping. This is just a prep for what's going to come. Makes sense, right? All right. Let's launch this missile one more time. But this time, we're going to have another observer. What if there is a very fast-moving spaceship at the same location? Okay, so when the explosion happens, there just happens to be another fast-moving spaceship moving to the right, pretty much at the same location. It's at the, you can imagine it's at the same location as where the astronaut is. I've just shown it over here so that we can see it, but it's at the same location as where the astronaut is. Okay, Einstein asks.
This is the train scenario of simultaneity versus like someone moving past. It's the same thing, only he's put it in space.
What will the people inside the spaceship see right now? What do you think?
Give me a second.
Right now. What do you think? Well, because they're at the same location at...
The information of the boom takes shorter time to send to the ship than the light of the explosion. Unless you're moving the ship faster than the speed of light, it won't even reach it.
As the astronaut, they would get the same light as the astronaut is getting. Therefore, they would also see the boom and the missile being launched at the same time. Look, you can see that over here, just like what the astronaut got. But now here's the key question that Einstein asks us, okay? Both will agree that the boom happened right now because this is happening right now. But from the astronaut's perspective, she says that, hey, this missile was fired 1 year ago. Now the big question Einstein asks is, what about the people over here? What would they conclude? When was the missile fired from their perspective? And my first reaction is, well, it has to be the same, right? Like all the calculations would be the same, right? But Einstein says no. From their perspective, they will find that the missile was fired just a few months ago. And I'm like, wait a second, what? Why, Einstein? Why would these people conclude that the missile was fired just a few months ago? How does that make any sense? And Einstein says, Mahesh, I wish I could give you a simulation to show you what's really happening, what I'm thinking in my head. Unfortunately, I can't do that. But yes, where we can do it, we can do it on brilliant.org, the sponsor of this video. Okay, seriously, why do I recommend Brilliant all the time? Because unlike watching videos, Brilliant has interactive lessons in math, science, data, programming, and even AI. I've been recommending them to my students for
brainwash you and you paid for it.
years because it's really hands-on and that makes learning really effective. Also, guess what? Their lessons are bite-sized, which you can cover in about 15 to 20 minutes. This means with just a few minutes every single day, you can actually enhance your problem-solving skills. I mean, how cool is that? For example, have you wondered how ChatGPT really works? Well, then you can try their course on large language models, LLMs. Again, right off the bat, you will start interacting with it and you will uncover how these models build vocabulary, what training really means, and how can you even tune them to generate different outputs based on different contexts.
You know large language models will be obsolete when you get a proper AI, right?
So if you think all of this is awesome, then guess what? You can try everything Brilliant has to offer for free for a full 30 days. Again, why would the people over here conclude that the missile was fired just a few months ago? Einstein, what's going on over here? I mean, the light has been traveling for 1 year, right? So why would they conclude that? Well, Einstein says, Mahesh, this light has not been traveling for 1 year from their perspective. And I'm like, wait a second, how does that make any sense? What are you saying? Okay, so from their perspective, they're at rest, and the rest of the universe is moving to the left, isn't it? And I'm like, yeah. Now remember, when things are moving very close to the speed of light, they contract in the direction of the motion. Now the same thing should have happened.
I'm sorry, but an explosion or light coming from the ship of the rocket being sent, if you could even see that, launch, the universe isn't moving to the left, it's the rocket that's moving. If you let me put it to you this way. Let's send a bunch of faster than light speed rockets in random directions and see how that squashes the universe. Oh, it doesn't do that? No, because that'd be freaking weird.
Over here, and the spaceship should have also been contracted, but Mahesh, you forgot to animate that, and I'm very sorry to do that. Yes, this spaceship should have been contracted, but anyways, from the spaceship's perspective, everything gets contracted, which means, notice, that destroyer is not 1 light year away from the explosion or from the moon. So from the...
When you get into length contraction and stuff, you're thinking that the object is going to squish as it's going faster. There are two things that happen when you go faster. The first thing, you get pressed against the back of your seat. It's the force of your momentum clashing with the momentum of the ship. You end up crushed. That's called gravity. Length contraction the ship doesn't freaking change. You shot a rocket, the ship isn't gonna just change. This is stupid.
Perspective of the people over here, the light came from here, right? No, says Einstein. There's a second thing that we need to take care of. Remember, these things are moving to the left. They're moving away from the spaceship. And this is the current location of the destroyer. But when that light was emitted back in the past...
Ship is over here. Over here is to the right for me. Whatever.
The destroyer must have been closer. Therefore, the light must have been emitted from somewhere over here. And if you calculate this distance, that happens to be a few months, say about 3 months. Don't worry too much about the numbers over here. It's not very accurate animation. What matters is that this distance is much smaller than a light year, and therefore, let's just assume it to be a few months, say
you know, if it's 3 months, it's a quarter of the distance. You can do that math. So you can know the quarter of the distance in your animation and be accurate. There's no reason for you to not do that. But we're going to say whatever.
3 months. So these people will conclude that this signal was sent 3 months ago, and therefore they will conclude that the missile was fired 3 months ago. What's interesting over here is that both these people are exactly seeing the same things, but their conclusion is very different. Their realities are very different. So if you were to look at things from their perspective, they would say that, first of all, the light signal wouldn't look like this. From their perspective, the light signal must only have a radius of 3 light months. And if you were to run the simulation back in time, it will look somewhat like this now. Here it goes. Boom. This is what happened when we go back in time. So if you go forward in time, it now makes sense as to why it only took 3 months to explode. Because look, first of all, the distances are very small with length contraction, and the moon is traveling to the left. Therefore, it only takes a few months for the explosion to happen. So notice, different people will disagree how long it took for the explosion.
If the ship is moving to the right, that moon is still not moving to the left. It's where it was. Or its motion could be in literally any direction. But we're going to pretend that, let's say it's stationary. The ship moving past it will see it as going that way, but it's not going to think that it went that way. It knows it's going the other way. right? You know where that moon was, and if you were to somehow, drop a buoy or something, you wouldn't come to the conclusion that it started, that for some reason as you're moving to the right. Does anyone agree with him? Like, you see a target that you're moving past, you don't conclude that the target was moving past you. It's not the same thing, because like I can move towards my cupboards. My cupboards are not moving towards me. Like, I can put my hand closer to the screen. My screen wasn't moving relative to my hand. Like, it was just staying there. Or relative to everything else, my screen was just staying there. My camera was just staying there. So me doing this doesn't mean that my camera was moving closer to my hand. This is my camera moving and my hand not moving. There's a lot of what visually and blah 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 that you can't or maybe cannot tell that is happening when the thing does a thing instead of the thing doing the other thing. But the thing about that, yeah, approaching when it comes to a camera, it doesn't look any different. The thing gets bigger, all of that stuff, blah blah blah. But if you actually know where stuff happens, you know reality. You won't come to these weird conclusions. I'm sorry. This is nonsense, and it's an F.
To happen, the time between the cause and effect. But notice that they agree that the if cause happened before the effect. In fact, everyone over here, regardless of how fast they're moving, whichever observer you consider, everyone over here will agree that the cause happened before the effect. The missile was launched.
You already said that the ship doesn't agree with that, because let's say that if the ship shoots a rocket that if it's a light year away and it took a second to shoot the thing, and you get the information from it a year later, you knew that it was sent, and then a year later you get the information of it exploding. For everyone else, it would take a year for it to know that a missile was sent, but that doesn't mean that you would conclude that the missile was sent somehow after the explosion. You would just assume that the light traveling is a fraction of the speed of the missile. You wouldn't think that it was going like the problem is it's convoluted with length contraction. It's hard to really put an argument up when it is regarding length contraction, because that's like something I can't at the moment speak towards. Give me a couple moments, I might be able to think of something. But no.
Launched before the explosion happened. Everything is fine, causality is fine. But now, let's consider what happens when missiles are traveling faster than light.
Okay, so we're getting into the weeds now.
Let's consider what happens when missiles are traveling faster than light. This time we have a missile that's traveling 4 times the speed of light, which means when it goes from here to here, it'll take not 1 year, but only 1/4 of the year, meaning just 3 months.
Yeah.
Boom. So the difference between the cause and the effect is just 3 months. Okay? Time difference, I mean.
Yeah. And the signal of it being shot will still take a year for it to get there. I've already covered this.
But again, Einstein asks Mahesh, what does she see this time? Ooh, interesting. The missile is traveling very quickly. That means if you were to see the light signal.
Look, if I look at any two things that are going at different speeds, I can calculate if I know the distance, then I can calculate whatever the speed was. I can consolidate that, yeah, it just went at different speeds.
Oh, let's look at it one more time. There we go. Whoa! She sees the boom first, of course, because the light from here is yet to reach her. So she sees the boom first, and then after some time, she will see the missile being launched. Oh my god!
It's just like with the difference between a lightning strike, where you hear it and then you see it. For some reason, if you were to go faster than the speed of light with the sonic signal, like if you were to speed up the sound faster, then you would hear it before you see it. And Einstein says, no. That's not going to happen. But if you did, you would hear about it before you saw it. And for some reason, that's weird. But we all know that, like, the speed of sound is obviously smaller than the speed of light. The question is, what happens with stuff when you go faster than the speed of light? The simple answer is we don't know, because nothing has been tracked as moving faster than the speed of light. Except for Cherenkov radiation, because that's the speed of light in water.
Like, wait a second, she's seeing things in reverse. She is seeing the explosion first, and maybe she'll also see the missile being here later, and then the missile being here, and then the missile being here. Oh my god, she's...
I know, but the guy sent the thing. He knows... The guy who sent it knows that it's going to take, again, 15 months for that explosion to get to him, because it was 4 times the speed of light, or 3 months for it to travel there, and 12 to get the light signal back. He finds out about it 15 months later. No biggie.
Sees the whole thing uncovering backwards. Wow, it would be so fascinating. So this is...
Doesn't break reality saying that it actually happened backwards.
it, right? So causality is broken. She's seeing the effect before.
No, signals are just sent at different times. Causality doesn't give a shit.
The cause? Is this what you were talking about, Einstein? And Einstein says, Mahesh, no. This is what she sees. Remember, we need to figure out what happens from her perspective to understand whether causality is broken or not. So don't jump the gun yet. I'm like, okay, cool. All right, let's do that. How do we figure this out? Well, again, from her perspective, the boom happened right now. How long will she have to wait for this light signal to reach her? Well, 3 months have passed because it took 3 months. So in that 3 months, the light must have traveled 3 light months. The light
9 more months.
Still needs to travel the rest of the year, which is 9 more months, 9 more light months, which means the light will take another 9 months to reach her. So let's look at that. This is another 9 months. There it goes. Here it goes. And yeah, 9 months later, she will receive the signal. But wait a second. The astronaut knows. She knows that this signal was originated 1 year ago. So it was originated 1 year ago, but she
Yeah. She sees it as it happened 9 months ago. Reality says it was a year ago. So you saw you saw stuff that you weren't compensating for, or whatever. Well, here's the thing, right? The light signal said independently of the missile. It took a year. But she doesn't know when those 3 months. Knowing the speed of light, she would know that if it happened 9 months ago, but the other thing is there's other ways of knowing the distance of stuff. We don't approach questions and issues like this. We actually do proper calculations for the distance of things. You could also say that, okay, 3 months prior to the explosion, the initial launch was sent, the light travel. Again, it's more simple.
got it 9 months after the boom, that means it was created 3 months before the boom. So she will realize that even though she saw the whole thing in backwards, it was a fascinating thing for her to witness, one in a lifetime opportunity to do all of this, all of that is great. But she will realize that even though she saw it that way, that was an illusion. What really happened is that the missile was fired 3 months before the boom happened, explosion happened. So causality is not broken. The cause comes before the effect. Everything is fine. Okay. Then Einstein, why did you say that the causality gets broken? Clearly, we are seeing the causality is not broken. Einstein says, Mahesh, but what if when this boom happened, there happened to be a spaceship nearby? Again, moving very close to the speed of light to the right. What will things look like from their perspective, and what would they conclude? This is the key moment. Okay, let's uncover this. First of all, just now boom has happened. Just now the explosion has happened and the spaceship is very close or right over there at where the astronaut was. So even the person over here would see the boom right now. Okay, when will they see the missile being launched? Well, for that, the light from here has to reach over here, and that will take some time. Let's see. So this is a reference to show when the boom happened. And now we have to wait. Oh my god, we're gonna have to wait a long time because this is traveling very close to the speed of light. Again, this should have been length contracted. I did not animate it right. Sorry for that again. But anyways, let's wait for it. Here it goes, here it goes, here it goes, here it goes. Come on, come on, come on, come on.
You know you can calculate your actual speed. It'll take so long for that signal to get there. What's your...
Come on, come on. There it goes. And... okay, there it is. They finally see the missile being launched. So they too see the things in reverse. They first saw the explosion, and then after a long time, they saw the missile being launched, right? And again, Einstein says, Mahesh, be very careful. This whole thing is from our perspective. From our perspective, the light went from here to here. It traveled great distances. But what does it all mean from their perspective? What would they conclude? When was this light signal originated? When did this boom happen? What would they now conclude? That is the big question. This is the key moment. This is the climax, folks. How do we figure this out? We've done this before. We just transform into their reference frame and take care of two things. So when we jump into their reference frame, the first thing we do is we length contract the rest of the universe. So when we do that,
Why?
let's do that. There we go. All right. So the destroyer is a little closer. Does that mean from their perspective the light comes from here? No. Remember, the whole thing, the whole universe is moving to the left. And so this is the current location of the destroyer. But when the light was emitted, when the missile was launched, when the light was emitted from the destroyer, it was closer, which means, again, it was somewhere over here. So the people over here will conclude that this light came from here. It has been traveling from here to here. So that's when that happened. So to figure out exactly when it happened, we have to go back in time and see when the light converges over here.
No.
And when did the boom happen? Can you see something? Can you actually see something? The boom happened when the plane was over here. So let's now turn back the time and see what it all means from the plane's perspective. Let's do that. Here we go. This is what it looks like from the plane's perspective. Let's turn back, and we don't really care about exact time. What we care about is when does the cause happen, when does the missile get fired, and when does the boom happen? Which happens first? That's what we're interested in. So let's look at it. Let's go back in time. Let's do the whole thing in time. They're becoming closer, and when this thing converges, that's when the missile was fired. And here it is. This is the moment when the missile was fired. But what's interesting is that the boom is yet to happen in the past. It's further in the past.
You know? Here's the thing.
Can you see what's going on? It'll make sense. Let's just roll with it. Let's do the animation. We're going back in time. Let's run it back in time. You say that, okay, now I have to further wait and go back in time to figure out exactly when the boom happened. This is when the boom happened. So look, the boom happened even more in the past, which means the boom happened first, then the missile got launched from their perspective.
The signal of the missile reaching them by a measurement which is the speed of light, which is a constant we're able to understand. So we know that it's possible to know when the actual boom happened. But when you're moving, length contraction is like hidden variable or whatever, but like as you move, if your perspective becomes length contracted, then again compensate for it, because you still have understanding of what it's like when you're moving at not the speed of light. there's ways of knowing objective truth. There's ways of sussing this out correctly. I think you're missing. Maybe I'm not in the right mental space to really comprehend length contraction and to be able to say right or wrong or whatever about it. But the reality is, the perspective of the other person doesn't change when things happen. Because anyone could be traveling in any direction. And, like, if they were moving, for example, towards the spaceship that shot the rocket, well, that means that they're gonna see the boom maybe first, and it'll still take them, well, less time than light, because if they're going the speed of light towards, from the boom to the ship, then it'll take, again, if it's a light year, it'll take 6 months for them to realize that one thing has happened, the missile getting shot. But because they're moving at the speed of light, they'll never find out the boom happened if they were past the moon when the boom happened. So that's where, because if you're going the speed of light, the information of the rocket being sent will definitely get to you. It only takes 6 months, and you can calculate all that, but because the boom information is behind you when it happened, you're already 6 months that way. You would have to slow down in order to ever get the information about the explosion. But then that versus like a standard candle or a beacon or something, you'd be able to know when it happened and where it happened and whatever. So, a ship moving the opposite direction of all of this stuff has a completely different perspective than the guy moving the same direction as all of this stuff. I'm going to ignore length contraction because that is a perspective thing and not a reality thing. Because it doesn't change what happens with reality. And if stuff gets length contracted as it is moving, it's the stuff that gets length contracted as it's moving. The ship would be length contracted. The missile would be length contracted. Not the one that sent it. Not the moon. Not the rest of space. Only those two items. And that's... again, that's an if.
So they would conclude that it happened the other way around. Again, if we run the whole thing forward, it'll make sense. Let's run it forward. Okay, here we go. So first the explosion happens. They also instantly see the explosion. And then after some time, now the missile gets launched. And then the light signal of that missile being launched gets created.
No one will conclude that the missile got launched second. Again, if you're going fast enough, if the ship is going slightly faster than the speed of light, if the boom signal gets to it because it happened in front of the ship, You will never get the signal of what's happening when the ship was launched. Because you're going faster than the signal can get to you. So if the boom's happening in front of you, you'll get that information. Everything else behind will not even catch up with you. If you're going under the speed of light, it'll catch up with you eventually. But that doesn't matter, because stationary observers know what actually happened. Moving reference frame is you have to compensate for your own speed, right? Just like in football, you have to compensate for the speed of the ball and the speed of the runner. As you're throwing, you don't want to shoot past them, so you shoot it faster or further. And that's something that my brain was like, I don't know how fast they're firing the ball. I don't know where they're aiming it to go. I don't know how to actually calculate where it's supposed to be. They did not do proper calculations about all that stuff and how to do it like in a slow way and then expect it to be able to be done in real time. They just went into the deep end and tried thinking that my brain, which analyzes things too much, can't calculate that distance and your speed of the ball. Because you would fire it and, okay, you're expecting me to be here when it's landing, and what if I'm not there? Or what if I'm, it's like they make a pitch, they expect it to hit there. Even if they hit it where they assume they're going to hit it right there, my brain is compensating for where the hell do I expect this ball to go? And I don't have the experience of that. So my own brain cannot do the calculations and know that I need to have my hands out like here or behind me or what in order to catch the ball, and I don't catch it. Because I don't have experience with balls being thrown at me. If everyone else who knows how to play the game and has done it for years is able to do that because their brains have been trained with that information, they're able to make those compensations. They compensate for their own motion and the motion of the ball. They get it right, they catch the ball. It happens all the time in football. That's the whole thing. There is some illusion that there is some mentality that says going faster than the speed of light is going to change that dynamic. You moving and this thing moving along with you. I'm here to tell you there's nothing that's going to change. And I'm sorry, but I'm not wrong. And your enthusiasm is admirable, but I just wish you were saying something correct. And you said a lot of things in this video that I'm going to say, maybe you don't deserve an F. Maybe you deserve a D or a C, because you get a lot of this stuff right, and really all you're getting wrong is, again, stuff that you've been taught. Because obviously you're referencing Einstein, you're referencing the fact that a moving thing has a different observation, and yes, the moving thing has a different observation, but it doesn't change the order of events. And who gives a shit what you observe? It doesn't change the order of events.
And then we'll have to wait a long time for that light to eventually reach them. So look, the explosion actually happened first before the missile being launched. This is what their reality is. But wait a second, how does...
That's not what their reality is. They would do proper calculations, they'd know when it happened.
that make any sense? What does it all mean? Well, not only is this event of explosion happening before the missile being launched, they will find that after the explosion happens, after that, the missile comes here. Then the missile comes here. All the events over here are actually happening in reverse. They're not just seeing it, but it's actually happening in reverse from their perspective. So if you look at the whole thing one more time, this is their reality, boom, and then the whole missile, in fact, travels backwards.
Let me explain something to you. What he's trying to say here. The missile's going 4 times the speed of light. Meaning, if it's able to reflect light at all of those different instances will be that would be smushed together. But again, that's the signals of the light. In order for light to travel, let's limit it down to a few seconds. Let's say that it, or even less. Let's say that it takes a fraction of a second of this rocket's travel. Light is still going to take, let's do just 1 second. So 1 second of this rocket's travel, it'll take light 4 more seconds for that information to move forward and end up at the moon. And every step like that is like, okay, it happened to be here, but what we're seeing is that happening later and later and later and later, taking like 16 seconds for us to even notice that it happened 4 seconds ago. Again, this is about the signal versus the actual event. Or the same can be happened with the difference between light from the lightning bolt hitting first and the boom comes after. Because the boom is slower. There's no confusion about that. Everything makes sense. And for some reason, we're expecting it to be different when you go faster than the speed of light. And I can't help but tell you that my brain is just not going, besides the fact that it's not going to accept it, it just doesn't matter because it doesn't change what actually happens.
This is their reality. So again, just to clarify, the astronaut too saw things backwards. But when she did the physics, she realized, no, things actually happened forward. The missile was launched first, and then the explosion happened.
Yeah.
The people in the spaceship also saw the things backward, but when they did the physics, they realized that it actually happened backwards. The explosion did first happen for them first, and then the missile was launched. The whole thing actually happened.
Again, being super enthusiastic like this, you can become not. I mean, it's a neat thing to have. The revelation of it, the idea of it, it's a wow. This happened and stuff. But I feel like you can be not subjective. Like if you don't present it as something that you're happy about, I mean, how does that make a good video? But the problem with being too elated with the idea is that you can lose objectivity.
upwards. Causality got broken. Okay, so this can have many questions now. We might have many questions. First of all, what's the problem if the causality is broken, Einstein? I ask. Well, even if it's broken, even if they conclude that the explosion happened first and then the missile got fired, so what? It's all happened already. They can't influence anything anymore, right? Einstein says, well, what if we rerun the experiment? I mean, think about it. If we were to redo this experiment and now we know all the experimental parameters, if we rerun the experiment, the explosion happens first and they will instantly see that explosion because they are at that location, so they don't have to wait for the light to reach them. They're really there, so they'll instantly see the explosion. They'll know the explosion happened, and what they can do now is they can now send a faster than light signal to the destroyer and say that, hey, don't fire any missile. And now what will happen if the people in the destroyer agree to that and they do not launch a missile? What happens now? The explosion has already happened, but there is no missile being launched. How do you make sense of this? How does it all make sense from the perspective of the astronaut, meaning you?
Okay. Order of events. What is actually happening here? First of all, does it make any difference how fast your signal is versus how fast the missile is? Well, let's say that we do a simple thing and say that it took 3 months for the missile to go from there to here, but it only took 2 months for you to send a signal that goes from here to there. There's still positive in all of that. They don't negate each other. They don't like, right? You find out about it and then you send a signal that is moving so fast that somehow it's supposed to, like, when is it actually going to reach them relative to when you actually launch the missile? And the answer is, you add them together. It was sent with 3 months. You sent it in 2. So 5 months, right? You get this signal of it happening. You don't really see the explosion for another, you don't see the light regular signal for another 7 months. So you get the signal of it happening because of the faster than light signal, and then you actually see it happening again. That's just 2 signals at different speeds saying something happened. It's the lightning light and the boom of the sound. It's not like you're sending a signal back in time somehow.
You and I, from our perspective, how does it all make sense? The universe gets broken, paradoxes get created. This is why, for the universe to be sane, causality should not be broken, which means every single observer, regardless of how fast they're traveling, should agree in their frame the cause should come before the effect. And since faster than light signals break causality, this is an argument against faster than light signals. This is how we can conclude that faster than light signals cannot exist. So things like tachyons should not.
Listen, again, faster than light in a what? So again, light in a liquid. like water, is slower. So you end up with Cherenkov radiation, which is the particles moving faster than the light can go. They literally are sent out at a speed that light in that fluid is not able to move. Fascinating that that can even happen. But again, doesn't matter.
Not exist. But that now brings us to the
So the tachyons and stuff moving faster than light. The tachyon is a Cherenkov radiation particle, only instead of moving through water, it's the same idea, but it's happening in space, like in an empty atmosphere, or in like not even in air, not even a gas. Like you empty it out, it's moving faster than light. That the whole thing. The whole thing about paradoxes with this, your signal's happening differently. Again, if you send the signal so that it only takes 2 months to get there, and the light from it is still going to take 12 months to get there, that's 10 months before you, in between. What did I say before? Okay, you send, because I calculated it with the 3 months it took for you to send the rocket, 2 months to send the signal back. You hear about it 5 months later. You see it happening 7 months after that. I'm still not wrong about that math. The thing is that, okay, you get the faster than light signal, which only took 2 months. It takes 10 months for that light signal to finally reach you, the visibility of it. But pretend that that slower light signal is just the sound of the lightning. Your brain doesn't melt, it just makes sense, it just is normal, it's fine. Causality doesn't give a shit. Everything's regular. It's fully understood, completely mathematically sound, no paradoxes. Everything is simple.
one last question. An important question that we could be having over here is that, we could tell Einstein, hey, you know what, in this specific example, that kind of made sense. But in general, if you were to zoom out a little bit, what's really going on? Why is it that if signals are traveling slower than the speed of light, everybody agrees on causality, it gets maintained, but the moment signal passes that threshold, goes faster than the speed of light, now suddenly some observers will pop up and in their reference frame, causality gets broken. Why does the universe conspire that way? Like, why does it all happen? Like, I still don't get it. Like, I'm not able to put it all together. What's going on over here, Einstein? Come on.
What makes you think this idea? And the answer is, we haven't observed anything moving faster than the speed of light. It's a conjecture. It's a myth.
It's time to put everything into perspective and reap the benefits of our hard work. Are you ready? Again, if you use a slower than light missile, then light overtakes it, of course. Now notice the cause signal is completely encompassing the effect signal, right? Now, if I transform it to some other reference frame, this was the reference frame from the astronaut, our reference frame. We're all at rest. Now, if we jump into some other reference frame, a moving frame, these distances will change, okay? But whatever you do, this yellow signal, the effect signal, should be on the left side of the cause signal over here. Similarly, the effect signal over here must be on the right side of the cause over here. The relative position should get maintained, because transformations, when you do a transformation, you're only dividing or multiplying by something. When you divide or multiply by something, this thing will shrink, or this distance will become bigger, but this can never come out. This can never come out, right?